Okay, so for problem 25, we're going to find the critical values, and to do that, we take the first derivative, and when you take your first derivative, you should be getting x squared minus 15x plus 54, and you should see that that is easily factorable into these factors, set them equal to 0, and you get critical values of 6 and 9. So now we're going to do a sign chart, and when you do that, you should be getting the following signs, and those signs indicate a max and then a min. So you could say that, well, let's go on the next page, and you can say at the CV of 6, our slope changes from positive to negative, and so therefore you have a max. Meanwhile, at the CV of 9, that slope changes from negative to positive, and therefore you have a min. Okay, so if they ask you for the critical points, you're going to plug in the 6 in the original function, and you will get this for your max, and then you're going to get this for your min. Okay, we're going to go to the next page, and they want us to figure out the inflection point. So let me backtrack for a second. So if you take your second derivative, you should find that you get 2x minus 15. Set that equal to 0 for your inflection point, and you end up with x equals 7.5 or 7.5. And when you plug that into your original function, you should get a point of 128.8 for your y value, and that falls between the 6 and the 9, so that makes sense that that is our inflection point.